Okay, this is Mrs. Nikita, and we are going to work together to solve question number 4 in your momentum problems. All right, so we're going to read the question and decide whether it's an elastic or an inelastic collision. Judy, who has a mass of 40 kilograms, standing on slippery ice, catches her leaping dog, who has a mass of 15 kilograms, moving horizontally at 3 meters per second. Show that the speed of Judy and her dog after the catch is 0.8 meters per second. Okay, so they give you the answer, so you need to work towards it. So we need to find out whether or not this is an elastic or inelastic collision. But before we do that, we need the law of conservation, which says that momentum before equals momentum after. All right, we start with Judy's mass of 40 kilograms times her initial velocity, since she is standing, that's 0, okay, plus the dog's mass of 15 kilograms times his initial velocity of 3 meters per second. Okay, all of that is equal to the momentum after, which when it says that she catches the leaping dog, it means the two are joined together now. So it's an inelastic collision, which means the mass after has to be added together. So 40 kilograms plus 15 kilograms, okay, all times the velocity after. Okay, so the two are equal. So we're going to go ahead and solve. We can eliminate this term because anything times 0 is 0. 15 times 3 is 45 kilogram meters per second. And that all equals 40 plus 15, which is 55 kilograms times VA. All right, let's solve for VA. Divide by 55 to get it by itself. Divide by 55. Okay. And we have VA equals 45 over 55. Using your calculator, you would find that VA calculates out to be 0.881 meters per second. Okay. Do they match up? Have I shown that the speed of Judy and her dog after the catch is 0.8 meters per second? Yes, I have. All right, so inelastic collision. Why is it inelastic? Because the two go off together. They move off together, both the dog and Judy. All right, so now you know how to do an inelastic collision. Go ahead and write this in your notebook because you're going to turn this in. And we'll practice an elastic collision. Hi, this is Mrs. Nikita. This is our second problem from the chapter problems, number 8. Comic strip superhero Superman meets an asteroid in outer space and hurls it at 800 meters per second, as fast as a bullet. The asteroid is 1,000 times more massive than Superman. In the strip, Superman is seen at rest after the throw. Taking physics into account, what would be his recoil velocity? Okay, so just like the skateboard when we threw the ball going in one direction, right, forces the skateboarder in the opposite direction. Momentum is conserved. Right, so we know that M2, which we're going to call the mass of the asteroid, at 800 meters per second. So we've got MV minus M1, which is the mass of Superman, times the velocity, recoil velocity, which is the velocity he will take off at, okay, must equal 0 in order for motion to be conserved. All right, so we still have too many variables here, but they give us another piece of information. They say that the asteroid is 1,000 times more massive than Superman. Okay, so we're going to M2 equals 1,000 M1. Okay, with that piece of information, we can solve this. 1,000 M1 times 800 meters per second, and then we'll put this on the other side, plus M1 VR. So we add this to the other side so that we can isolate the recoil velocity. All right, divide both sides by M1, and M1 becomes 1 on both sides, which means it goes away as a variable. So now we have 1,000 times 800, which is 800,000 meters per second, equal to the recoil velocity of Superman. Okay, which makes sense because if you hurl something super big, okay, and you are super small, it's going to hurl you back, okay, at a much greater speed in order that momentum is conserved. Make sure you complete this problem, okay, with the help of this video. Okay. Make sure you understand it because you'll have a similar one, okay, on the quiz. Good luck.